Good morning students, welcome to 9th class mathematics. We are discussing first chapter real numbers. So in the real numbers we are discussing about irrational numbers. We have completed irrational numbers topic up to converting root 2, root 3, root 5, square root of non-perfect square numbers into decimal form. Now second topic in the irrational number, finding irrational numbers between two rational numbers. In the rational numbers topic, we have discussed rational numbers between two rational numbers. Now, irrational numbers between two rational numbers, that is non-terminating, non-recurring decimals in between two rational numbers, or square root of non-perfect square numbers in between two rational numbers. So, let us discuss. Find any two irrational numbers between 1 by 5 and 2 by 7. Now to find two irrational numbers, any two irrational numbers between 1 by 5 and 2 by 7. To find irrational numbers, that is non-terminating, non-recurring decimals or square root of non-perfect square numbers, we have to convert this fraction form into decimal form. This fraction form into decimal form. Now we find two or more than two non-terminating, non-recurring decimals between these two rational numbers. First step is to convert this rational number into decimal form. That is dividing 1 with 5. 1 by 5 means divide 1 with 5. So 0 point, because 5 does not divide 1 exactly one time. So 0 .10. So 1 5 is 5, 2 5 is 10. So this is 0. So 1 by 5 means 0 0.2. This is a terminating decimal. Now we have to divide 2 with 7. So 2 by 7. Divide 2 with 7. 7 divides 2 0 times. That is 0 .7 1s are 7. 7 2s are 14. 7 3s are 21 is more than 20. So 20 minus 14, 6. Now we have already placed one decimal point, 0. 7 8 56. Now the difference is 4, 0. 7 5s 35, 5, 0. 7 7s 49, 1, 0. Now it is continuing like that. It is a non-terminating recurring decimal. So 10. Now 7 2s 14, 7 1s 7. So 10 minus 7, 3. Now becomes 30. 7 3s 21, 7 4s 28, 2. Now 20. Again you come to first point, 20. So now 20. That means again this pattern will be repeated. 2 8 5 7 1 4 will be repeated. That means 2 by 7 means 0 .285714 bar. That means this pattern will be repeated. Now we have to find a non-terminating, non-recurring decimal between these two decimal numbers. That means an irrational number between 0.2 and 0.285714 bar. That means again 285714 bar. Now a non-terminating, non-recurring decimal between these two is, that means 0.2 means we can write any number of zeros, 0.20000. That means 0.20, 0.28. In between, we have to find an irrational number between 0.2 and 0.285714 bar is 0.20200020000000. This is a non-terminating, non-recurring decimal. Now, if you want to write another in between 0.20 and 0.28, 20 and 28, 21, 22, 23, so on. So, another rational number, if you want to write another rational number. So, here the question is write two irrational numbers. Finding irrational numbers between two rational numbers. So, you can write any number of irrational numbers. If you want to write another irrational numbers between 0.20 and 0.285714, you want to write another non-terminating, non-recurring decimal. 0.21, 211, 2111, 2111. That means this is not a repeating pattern. You can write any non-terminating, non-recurring decimal between two rational numbers. So, to find a non-terminating, non-recurring decimal, that means an irrational number between two rational numbers, first convert the fraction into decimal form by division. Then find two decimal numbers. In between those two decimal numbers, first find first two decimals. In between these two decimals, we can write any number of non-terminating, non-recurring decimals. If those are equal, then go for next decimal. Like that, we can find any number of non-terminating, non-recurring decimal between two rational numbers. There is another method to find any number of irrational numbers between two rational numbers. Let us go for that method. So next example, find an irrational number between 3 and 4. So now we have to find an irrational number between two rational numbers, 3 and 4, or two integers, 3 and 4. We cannot find any integer between 3 and 4, but we already found a rational number between 3 and 4. That is 3 and a half, like that. Now we have to find an irrational number between 3 and 4. You can write directly between 3 and 4 a non-terminating, non-recurring decimal. That is 3.12312341234 This is an irrational number between so on. An irrational number between 3 and 4. Now, another method to find an irrational number between two rational numbers. There is a process. If A and B, that is A is a rational number, B is a rational number, A and B are two positive rational numbers. Here in the place of A there is 3, in the place of B there is 4. Such that AB, that means A into B. You have to multiply these two numbers, A into B. If it is not a perfect square, you know the perfect square numbers. 1 square 1, 2 square 4, 3 square 9, 4 square 16, 5 square 25. We multiply these two, the result is not a perfect square. For example, 3 into 4, 12. 12 is not a perfect square. A into B is not a perfect square of a rational number, is not a perfect square. Then square root of A into B, square root of A into B, that means square root of 3 into 4 is an irrational number between those two rational numbers. Those two rational numbers are A and B, that means here 3 and 4. That means simply an irrational number between, that means a non-terminating, non-recurring decimal between 3 and 4 is square root of A into B, that is square root of 3 into 4. Square root of 3 into 4 means square root of 12. It is otherwise solved as square root of 3 into 4, square root of 3 into square root of 4. Square root of 3 is not a perfect square, square root of 3. Square root of 4 means 2. In the order we can write 2 root 3. So, root 12 lies between 3 and 4. Root 12 is an irrational number lies between 3 and 4. Or otherwise you can say 2 root 3 lies between 3 and 4. So an irrational number between 3 and 4 is root 12 or both are same. Here we separated root 3, root 4. Here we are write the direct product. So root 12 or you can simply say 2 root 3. So 2 root 3 is an irrational number lies between two rational numbers 3 and 4. This is another method of finding an irrational number between two rational numbers if the product is not a perfect square. So you have to multiply the given two numbers. If it is not a perfect square, then you can follow this method. In the beginning of irrational numbers topic, we have already discussed some examples of irrational numbers like non-terminating, non-recurring decimals, square root of non-perfect square numbers, and pi is also an example of irrational. Is pi irrational? How pi is an irrational? What is meant by pi? For which ratio we use pi? So generally pi is the ratio between circumference and diameter of a circle. It is a ratio between circumference and diameter of a circle. Do you know what is circumference? The boundary, the length of the boundary of the circle is circumference. A line which divides the circle into two parts, which passes through the center, is diameter. This is diameter. If you divide the length of the circumference with the diameter, it gives 3.14, or we write the pi ratio is 22/7. Generally you know the value of pi. 3.14 or 22/7. That means circumference of a circle is more than 3 times the diameter. That means circumference is pi into d. That means 3.14 times the diameter. That is the circumference of the circle. But we are writing pi as 22/7, integer by integer. This is a rational number, but we are saying pi is a irrational number. Pi is an irrational number. So how pi is an irrational number when we are writing it in the form of a rational form? Actually, pi is an irrational number because the circumference by diameter is always a non-terminating, non-recurring decimal. So c by d, either circumference or diameter is a non-terminating, non-recurring, irrational number. The ratio is a non-terminating, non-recurring decimal. But why we are writing pi as 3.14? We terminated 3.1415 so on into 3.14 for our calculation. This is an approximate value, it is nearest value. We then convert into nearest rational number 22/7, or if you divide circumference with diameter, we get 3.1415 so on, a non-terminating, non-recurring decimal. We take it up to 3.14. Now the approximate value of 3.14 is 22/7. So we converted this into 22/7, 3.14, a rational form, but actual pi value is a non-terminating, non-recurring decimal, an irrational number. So in the textbook, page number 10, you can find to know about pi. So pi is a ratio between circumference and diameter of a circle. If you divide these two, we get a non-terminating, non-recurring decimal. So it is an irrational number. Pi is not a rational number, but 22/7 or 3.14 are approximate values, that means nearest values to solve the problems. To find the circumference of the circle or area of the circle. So the Greek genius Archimedes was the first to compute the value of pi. So Archimedes first computed the value of pi. He showed the value of pi lie between 3.140,845, 3.142,857. It lies between these two numbers. He showed that the value of pi lies between these two decimal numbers. So So later that Aryabhatta, a great Indian mathematician, found the value of pi correctly up to 4 decimals. So up to Aryabhatta found up to 3.1416 up to 4 decimals. So now using high speed computers or algorithms, pi has been computed over 1.24 trillion decimals. So now we are taking 3.14 is an approximate value. It is not a terminating decimal. It is a non-terminating, non-decaying decimal when we divide circumference with diameter. So pi is an irrational number since it is a non-terminating, non-decaying decimal. Next thing and discuss. Kruti said root 2 can be written as a root 2 by 1, which is in p by q form. So root 2 is a rational number. Do you agree with her statement? I have already proven that root 2 is a non-terminating, non-decaying decimal in the previous class. That is, the root 2 is an irrational number. But she said that root 2 can be written as in the form of p by q. We already discussed about 2 is a rational number since it is in the form of p by q. We can write in the form of p by q 2 by 1. But she wrote root 2 like it, root 2 by 1. This is in the form of p by q. So this is also a rational number. She said that root 2 can be written in the form of written as root 2 by 1, which is a rational form. Is it correct or not? But so the answer is no. Why? Because root 2, she said that the root 2 can be written as root 2 by 1, which is p by q form. So root 2 is a rational. If we take 2, if we write 2 by 1 can be written as a p by q form. So 2 is a rational number. Like that she said that root 2 can be written in the form of p by q root 2 by 1. So root 2 is also a rational number. But by the definition of rational numbers, what is the definition of rational number? The numbers, by definition of rational numbers, the numbers which can be written as, or expressed in the form of p by q are rational numbers. But there is a condition in the form of p by q where p and q are integers. What are integers? All the positive counting numbers, negative numbers and 0, and q not equal to 0 are rational numbers. But here she wrote root 2 as root 2 by 1. But root 2 by 1 is not a rational number. So root 2 is not a rational. We already proven that root 2 is a non-terminating, non-negative decimal. So root 2 is not a rational integer. So root 2 by 1 is not a rational number since integer by integer only a rational number. Here root 2 is an irrational number. 1 is a rational number or integer. A non-terminating, non-recurring decimal by integer gives a non-terminating, non-recurring decimal. So root 2 is not an integer. Therefore, root 2 by 1 is not a rational number. It is not a p by. Even if it is a p by q form, where p and q are integers, the condition is wrong here. Here root 2 is not an integer, 1 is an integer. So root 2 by 1 is not a rational number. It is an irrational number. So she said root 2 can be written as root 2 by 1, which is in p by q form. So root 2 is a rational number. This is false. Because root 2 by 1, root 2 is not an integer. So by the definition of rational numbers, numbers which can be written in the form of p by q, where p and q are integers, then only we can say that this is a rational number. So root 2 is not a rational number. Root 2 is an irrational number. It is a non-terminating, non-decaying decimal. So exercise 1.2, classify the following numbers as rational or irrational. So by the definition of rational number, irrational numbers, so we have to classify these are rational numbers or irrational. If they are non-terminating, recurring or terminating, or square root of perfect square numbers or p by q form. Now we say that those are rational numbers. If it is a non-terminating, non-recurring decimal or square root of non-perfect square numbers, we say that irrational numbers. So 27 is not a perfect square number. Perfect square numbers before and after 27, 25, 36. Square root of 25, 5. Square root of 36, 6. Square root of 27 is not a perfect square number. So it is a non-terminating, non-recurring decimal. So it is an irrational number. Next, square root of 441. You know what is the square root of 441? Let us check. 20 is 400, 21 square. That is 21 into 21. 2 ones 2, 2 2's 4. 1, 2 plus 2, 4. 441 is equal to 21. So it is an integer. So it is a rational number. So square root of 441 is a rational number. Next, 30.2323425 so on. It is a non-terminating, non-recurring decimal. So it is an irrational number. Here no pattern is repeating or no decimal is repeating. Next, 7.48484848 so on. That is, it is a non-terminating recurring decimal. What is recurring here? 7.48 bar. 48 is recurring. So non-terminating, the recurring decimal comes under rational numbers. So remaining problems you have solved by your own. By the definition of rational and irrational number, we can solve these classification. Root 27, root 441. Find the difference between these two. 27 is not a perfect square number, so it is an irrational. 441, 21 square, 21, 441. So it is an integer. It is a rational number. It is a non-terminating, non-recurring decimal, so it is an irrational number. 7.48 bar. Non-terminating recurring decimal is a rational number. Terminating, non-terminating recurring decimals comes under rational numbers. Non-terminating, non-recurring decimals and square root of non-perfect square numbers comes under irrational numbers. If it is in the p by q form, integer by integer rational number. If numerator and denominator or any denominator is not an integer, it is not a rational number. The question already discussed. 2 by 3, it is a rational number. Root 2 by 3, it is not a rational number since here numerator is not an integer, it is not an integer. So even if it is in the p by q form, it is an irrational number, non-terminating, non-recurring decimal. So third question, find an irrational number between 5 by 7 and 7 by 9. How many more there will be? So there are two methods. First one is converting this fraction into decimal form. This fraction into decimal form and finding non-terminating, non-recurring decimals in between these. Second method, if a and b are rational numbers, then square root of ab is an irrational number lies between these two when it is not a perfect square. A into b is not a perfect square. So it is an easy method. So an irrational number between, you have to find only one irrational number. An irrational number between, here in the place of a 5 by 7 and in the place of b 7 by 9 is square root of a into, that means 5 by 7 into 7 by 9. Since it is a multiplication, can cancel 7 and 7 1. So it becomes root of 5 by 9. That means root 5 means root 5. It is not a perfect square. Root 9. Root 9 means 3. So p by q form where p and q are not integers. So it is an irrational number lies between 5 by 7 and 7 by 9. This is one of the easiest method for finding only one irrational number between two rational numbers or two integers. Next, fourth question. Find two irrational numbers between 0.7 and 0.77. Here two are decimal numbers. It is a terminating decimal, it is also a terminating decimal. If the decimals are given, directly write non-terminating, non-recurring decimals between these two terminating decimals. So here 0.7 means you can write it 70 or 700 so. Here 0.70 or 0.77. Non-terminating, non-recurring decimal between these two. So let us write two irrational numbers. Two irrational numbers between 0.70 and 0.77 are, here look at this, 70, 77. In between 70 and 77 you can write non-terminating, non-recurring decimal like this, 0.7070070000. Here this is one example. We need to write two irrational numbers. So another one, 0.71, 711, 711, 7111. You can write any non-terminating, non-recurring decimal, but it is the easiest method to write non-terminating, non-recurring decimals between these two. If you want another irrational numbers, 0.72, 722, 722, so on. Otherwise, you can write 0.7, 1, 2, 3, 4, 5, 7, 2, 3, 8, 4, so on. It is a non-terminating, non-recurring decimal. Like this, you can write any number of non-terminating, non-recurring decimal between two decimal numbers. So, if the decimal is given, you can write directly like this. If the fraction or integers are given, you can use the method square root of a if the product is not a perfect square. So, assignment, classify the following as rational or irrational. First one root 39, second one root 81. Third one 11.2132 435 465. Verify they are terminating or non-terminating. 0.3030030003. Second question. Find an irrational number between 7 and 8. Third one. Find two irrational numbers between 0.52 and 0.58. In this question, when the decimals are given, first verify whether they are terminating or non-terminating. If it is terminating, it comes under rational number. If it is non-terminating, then verify whether it is non-terminating recurring or non-terminating non-recurring. That means non-repeat. In irrational number between 7 and 8, you can follow any one of the methods. Find two irrational numbers between 0.51 to 0.58. Those are decimals. You can write directly non-terminating, non-recurring decimals between these two. So solve these sums.